Good day everyone, and today we will be presenting about Microscopy 1. But before we begin, let me first introduce my groupmates. We have Bisak Trisha, Cantilio Carlin, Hayag John Peter, Marvida Marian, Payang Ellen May, and Reyes Mariah Kisha.
Reduction. In this laboratory activity, we observe different plant specimens under the microscope to understand their structures and life cycles by examining their clarity, color, size, and shape. We can better understand how these plants grow and reproduce. Upon the microscope we used, we determine that its high power objective is non-functional, which prevented us from observing the specimen at a high magnification. This means we could only view the sample as scanning in low power objectives only. The malfunction prevents us to completely provide the images of three different objectives.
Now, let's move on to the methodology. This section explains how we conduct our laboratory and the step we followed to gather accurate information. First, preparing the materials. Second, setting up the microscope and observing the specimens. Third, taking a picture through the microscope.
Result and discussion. This is our B136 peridotite firm potentium with a mature sporophyte compared to the online reference image. In our specimen on the left, the protalium looks pale and unstained, so that heart-shaped talus and the young sporophyte are visible but not very sharp. The reproductive structure are harder to distinguish because of tissue blend together. On the other hand, the reference image, the sample is stained, which highlights the cells, archegonia, antheridia, and sporophyte attachment area. The details are much clearer, making it easier to study organization of the gametophyte and early sporophyte.
Today, I will compare the gymnosperm stem that we saw under the microscope and the clearer picture I found online. So first, the picture we took under the microscope is a bit blurry. The cells are not very clear because it was under low power, so we can only see the general shape of the stem. We can tell that this is round and that there are some patterns inside, but the details are hard to see. On the other hand, the online picture is very clear and clean. The cells are easy to see and the parts of stem are more organized, so you can see the outer layer, the cortex, and the vascular bundles in the middle. Everything looks more detailed because the image is taken with better lighting and better focus.
In our actual microscopic images, the stem appeared blurry and lightly stained, so the vascular bundles and internal tissues were hard to identify. Only the general circular shape was visible under scanning and LPO. Meanwhile, the online image is clear, detailed, and strongly stained, showing the proper monocot arrangement of scattered vascular bundles and well-defined tissues.
Nymphaea leaf. Based on our laboratory image, we can see and identify the structure of the Nymphaea leaf from its upper epidermis, the compact palisade parenchyma beneath it, spongy parenchyma, the visible air sacs, and lower epidermis using a scanning and low objective. To compare our image with our reference picture, we can see that both are indeed similar, whereas you can clearly see the air sacs, which is the plant used for floating. It also similar in lower and upper epidermis. The palisade parenchyma also have the same structure. The difference is that the reference image is more sharply stained than our actual image.
Our microscope view showed the basic round shape and faint chambers, but the details were blurry and hard to see due to low magnification and lighting. The online image, however, is clear and well stained, showing distinct nucleus, visible ovules, and organized tissues. Both images show the same structure, but the online reference provides the detailed anatomy that is not visible in our actual slides.
As we compare both images, they show young plant root with the same basic structure like epidermis and central vascular tissues. They are visible under the low power.
In conclusion, the laboratory activity allowed us to observe and analyze plant specimens under the microscope, giving us insights into their structures and life cycles. Despite equipment's limitations, the activity strengthened our understanding of plant
activity helped us
anatomy
understand
and the
plant
role of
structure
proper
better.
laboratory tools
Even with
and
some
scientific study.
limitations, we learned a lot from observing the samples under the microscope.
So this is our references, the documentation,